Hi guys, so in this video I'm going to discuss the organism JC virus. This is really a microbiology video that is masquerading as a pathology video because JC virus is something that is just there. In fact, almost all of us, all of you watching it, are already infected with it. We just don't know it because for most of us it's asymptomatic. However, in some patients it becomes this horrible disease known as progressive multifocal leukoencephalopathy, or PML, and that's kind of the only readout of it. So we're covering the two conditions together in this one video. Okay, so what is it? Well, first off, it's a polyomavirus, which is not that different from the papillomavirus. We haven't really covered the human papillomaviruses yet, but these guys are kind of close cousins. Within the polyomaviridae family, it is a papovavirus, which basically tells you a couple things about it. It's a small, non-enveloped, circular, double-stranded DNA virus. So it's got an icosahedral nucleocapsid on the outside, but no host envelope. The reason I say it's small is, remember how I said that it's kind of similar to the papillomaviruses? They're a lot larger than the polyomaviruses. That's kind of the only difference there. This one is really difficult to grow in culture, and that has actually kind of slowed research on it. Part of the reason is that the cells that it likes to infect, glial cells, those are also pretty hard to culture. As somebody who worked on human astrocytes for a long time, I can tell you that there's a whole slew of problems with culturing those. There are some great techniques, but that also limits the ability to grow JC virus as well. So it's highly ubiquitous, like I said. Something like 70 to 90% of the population is infected with JC virus before the age of 15. Typically, though, it's really well controlled and it's asymptomatic, and it's controlled by the immune response. Now, I have a confession to make. Back when I was first teaching you the immune response, I told you that there were these immune privileged sites, like the brain, because the brain is encased in this hard thing we call the skull, and we don't like inflammation in there, so we just don't let the immune response in there. That's not entirely true. It's a bit of a lie. So we let it in there. We're just really, really careful about what happens in there. So there is kind of normal immune surveillance that kind of goes in, checks out to make sure everything is copacetic, and then heads back out. And these normal surveilling cells are normally able to quash any replication by JC virus on its own, because JC virus infects glial cells. Specifically, it infects oligodendrocytes. So we'll get into that a little bit more in a minute, but one of the problems we have is that sometimes during the course of patients' lives, they become immunosuppressed. And it's when they become immunosuppressed that JC virus takes advantage, that it strikes. And when it grows out, that we actually see disease. And like I said, the only disease that we associated with JC virus is PML. Okay, so first off, how do we get JC virus? JC virus likely enters the body through some sort of respiratory tract or tonsillar infection at some point in our lives. It then infects lymphocytes and the kidney with kind of minimal damage or response. It's able to establish infection in the kidneys, B cells, monocyte lineage cells, and kind of other cells, but replication is typically inhibited in an immunocompetent individual. However, in T-cell deficient patients, particularly T-cells, so I'm just going to throw that out there. Oh, gosh, I really need my pen back. This script is terrible. But anyway, in T-cell deficient patients, such as those with HIV or cancer, or those on immunosuppressive therapy, you can see viremia and replication of the virus. Now, it's not just being immunosuppressed, because people are immunosuppressed all the time. What we're looking for is immunosuppression of the brain, because that's where it's hanging out and that's where it's going to be a problem. So if for some reason you have some sort of functional immunosuppression of that natural immune surveillance of the brain, you are more susceptible to JC virus. So JC viruses cross the blood-brain barrier. They replicate in the endothelial cells of the blood-brain barrier, and they use the capillaries to get through. So then you have kind of abortive infection of astrocytes, and that can lead to kind of partial transformation, which basically leads to cells that look like a glioblastoma but they're not a glioblastoma. They're actually JC virus. You can also use the large T antigen, which is one of the early proteins that's created during viral replication, to basically distinguish, am I looking at glioblastoma or am I looking at a JC virus outgrowth? So that's kind of one way to distinguish. Another thing that happens that actually leads to the leukoencephalopathy is that you get this production infection of the oligodendrocytes, and that actually leads to kind of a demyelinating disease. So what are we actually seeing, and where are we seeing it? Clinically, it begins presenting as kind of a subacute mental status change. And then you have these focal deficits that begin to appear over weeks to months, usually associated with kind of diffuse abnormalities of the white matter. That's why it's called leukoencephalopathy, because we're talking about the white matter in particular. So we might see like cerebral hemiparesis or kind of throughout the nervous system. You might see aphasia, mental status change, headache, fever, occasionally, things like that. If you do neuroimaging, and I'll show an example of this in a minute, you're going to see non-enhancing lesions of the white matter. Remember, this is a demyelinating disease, so we're looking in the white matter and these lesions aren't enhancing the way we expect them to. Microscopic examination can really be useful because we'll see presence of the JC virus by looking for viral inclusions in the oligos. One of the most devastating things about PML, though, is that currently we don't really have a good treatment for it. We know it exists, but there is no treatment. So about 90% of patients who experience PML ultimately succumb to disease. Okay, so this is what I was talking about a minute ago, that we've got these white matter signal abnormalities. So the arrows are showing kind of this diffuse spread of non-enhancing lesions on the white matter. The white matter would typically be dark here. And here at the arrows, you're seeing kind of brighter colors. So it's just kind of diffuse lesions lighting them up. That's pretty characteristic of PML here. If we go ahead and take a look at the gross pathology, you can see kind of the multiple discolored lesions in the white matter. This obviously would be taken at autopsy. You just see these diffuse discolorations, and in this image it shows up as kind of like brownish lesions where you expect to see white matter. Then moving along, if we look into kind of like the histologic examination, we can actually see kind of this hypercellular lesions in the white matter. This is an example of the cerebellum. So at the top right, you can see these kind of granular cells and Purkinje cells of the cerebellum in this area. And then you see the white matter with the hypercellular lesions there. Okay, so the lesions, though, themselves can actually look very, very similar to glioma. So when you actually take those hypercellular lesions, they're very cellular. They have such high cellularity that people actually think it's a primary brain tumor. So how can we kind of distinguish it? Well, you have to look closer. So a clue to diagnosis is basically recognizing the numerous macrophages that you're seeing in here. And then additionally, these atypical astrocytes. Astrocytes are not permissive to JC virus infection, so that's why we get that abortive infection with astrocytes. So what you see is you kind of get these pleomorphic glial cells with these very abnormal nuclei, which is kind of what I'm showing here. And what they represent are astrocytes that have like attempted JC virus infection. And remember that the JC virus has that large T antigen, which is also an oncogene. So they just kind of look like cells in a glioma, but as you know, as Arnold Schwarzenegger said, it's not a tumor. It's something completely different. So the clue to making the diagnosis is to notice these foamy macrophages, foamy histiocytes. Then you can look at the edges of the cell for the viral inclusions, which are right here. So that's where you'll actually be able to find it. The oligodendrocytes particularly, which do accept productive infection by JC virus, are going to have these inclusions that pretty much just take over the cells. So when you see these massive viral inclusions, you know that you're dealing with PML. You can also do it by electron microscopy or immunohistochemistry, which specifically looks for JC antigen in tissue. So that's pretty much how we diagnose it. So when we're thinking about JC virus, remember, everybody's already got it. It's just when we become functionally immunocompromised in the brain that we actually see outgrowth of the virus, which leads to the progressive multifocal leukoencephalopathy, or PML, which unfortunately currently there is no treatment for. Thanks for watching.